Okay, welcome everyone to our November Zoom meeting for North Texas Microwave Society. We're happy that you're here. We've got a nice set of presentations, very current and I think important for the microwave community. And so we're going to have Dave start, and then we'll be Al Ward. And we have, I believe he has two presentations that he will initiate. And then I'll have something at the end about my trip to Tucson, where I took a bunch of pictures and tried to classify some other possible roving locations. So without any further delay, Dave, take it away.
Okay, well, evening all. First, a slight apology. There is some content in this slide that you guys will have all seen. But this presentation was originally put together for a microwave meeting on the Welsh border in 2 weeks' time. And they don't have some of the same background as the NTMS members do, particularly on the PFA. So those slides are in here. You've probably seen them all before, but let me just go through it. All right, GPSDOs, past and present, have been around for quite some time, as we shall shortly see. You can never have enough GPSDOs. I think there's actually 7 in that photo. The only one that isn't a GPSDO is the 2 boxes in the center, which are my CW skimmer boxes with a D to A converter. So there's 1, 2, 3, 4, 5, 6, 7 in that picture. Right, it goes back, I think, really to 2005 when M1JEZ came out with his design, which used a GPS with 10 kilohertz out and some CMOS chips, and you could use a variety of oscillators that you could lock up. It took me quite a while to get this diagram because it's very hard to find it on the internet. But I found one of the laptops I had in McKinney, and the assembly diagram was there. So that's from 2005. And here's the one that I built. You can see there's the GPS on the left and the processing board on the right. And there's a little, this is the days of RS-232. I don't think USB had been invented at this point. There's a little Max 232 chip that gave you the serial data out so you could set your PC clock. This one also has an extra, it has actually got a pick in it, which basically detects if there's 3 satellites or not, and lights that LED. You can see where it says no sats. It shows you when you shouldn't really be relying on the 10 megahertz output. So that was M1JZ, and some may remember my obsession with picks and clocks. And I actually put one in a box with a big digital clock so I could see what time was for skeds, etc. And that box is still in use, as you saw on the 3 back slides. HZ3801, which was going around the US. Not many in the UK have seen those because they were very expensive over here. I did see one listed the other day for, I think it was something like $500. I think they're now coming into rare collector's item. But as you can see on the right-hand side, I had to put a clock in this one as well, so I could see what time it was for skeds. 2012, TAPR negotiated with Jackson Labs for some very good 10 meg lock references. the $335 was about half what they were being sold for commercially at the time. And I've still got mine, and it still works. They've gone on. Jackson Labs have gone on to much more expensive and refined versions than this, but this was basically a development board type thing. USB, so you can get the NMEA strings out of it, 10 megs out of it, and you can see the reference oscillator is in the middle. I still use mine. As you can see on the left here, I got the module and a puck antenna, which sits on a metal plate inside this box, and an 8.4 battery pack, which is two 18650 cells, and they're all put inside a plastic box. Very important, that. But as you can see on the right-hand side, with you can see the boxes. It's got a square. The box has got a square box around it. I could just throw that in the heather and just take the 10 megs out of it. I don't trip over active antennas and rip them out of sockets and forget batteries and all that deal. That picture there was taken. That's on the opposite side of the Malvern Hills from where I live, and that's looking out towards Wales on the 24 gigahertz trophy that happened 2 months ago. The leading station on that had 27 QSOs on 24 gig, and his total kilometers was very impressive. The best DX was 180 kilometers, I think. Oh, here you can see the inside of how I squeeze it all in. The Jackson module is the black box in the center. The battery's on the left, and I had to have a metal plate in there because the GPS antenna's polar diagram was totally messed up if you just dangled it in the box. And you'll notice I put a rotary switch on it, because too many times when I've had a toggle switch on the output of the box, it's either been turned on and left on and flattened the battery, or it's sheared off the lever assembly. So now on stuff that goes out in the field, I always have rotary switches. And then at that point, V2ZAZ came along with his design, which used the 1 PPS out of a GPS module, and he had a pick and a counter and pre-scalers. And he had a pulse width modulator and a low pass filter. Again, it was TTL, so you had a TTL to RS-232 converter, and that had a pick controller. This is the one I had, I think, when I was in San Antonio. It's no longer with me because I think I took the ISO temp oscillator out for something else. But you can see again on the left, there's the GPS receiver, there's the reference, and there's a controller board behind. I seem to remember that had 4 10 meg outputs and one PPS output. Yeah. Then there seemed to be a flurry of CDMA base station 10 meg references. There was sort of like the Japanese equivalent of the Z3801 for the US market. I got mine through ARRL in 2016, I think. Yeah, it says here. It has a custom protocol, which was a bit annoying. The PACRATs did a controller design for it with an Arduino to allow you to control it and monitor it and put it into survey mode, etc. But they never did release the source code for it. And the one I built it and got it going, but the one thing that annoyed me was that the date was in the American format, and I didn't like that. So I looked elsewhere and found that somebody else had done some source code for it, which controlled it and had a display, and the code was available. One thing I should mention about this, although I got my board from PACRATs, when I turned it on, which was many years later, it had been put in fixed position very near Narita Airport in Japan. So when I turned it on, I thought it was in the center of Japan, which was quite surprising, meaning it was American service, but we soon put it to fixed mode and got it back into England. Here's the board. There were two versions of it. This is the later version. You can see bottom center, there's a Japanese GPS board. There's a CTS reference. Middle left, there's two, they did like their connectors. There's two 10 meg outputs on MMCXs. There's a 1 PPS on an SMB, I think. No, it's, forgot what that one is. The GPS antenna was on SMB. I had to get all sorts of adapter leads from AliExpress to put this in a box. And again, it has RS-232 on the board. You can run the whole thing off 12 volts, which is really, really good. And this is mine when I box it up. And as you saw from the earlier picture, this one is still in use. And you'll notice that it's got an Arduino Nano that's doing the controlling. And you'll also notice that it's got a linear power supply. This one does not have a switcher. Originally ran off a 12-volt battery, but for portable use. But then I converted it to a linear power supply. And on the front panel, there's a display which gives you the how locked it is and what the PPM offset is, etc. And then some of you may have seen this. In fact, they were around for quite some time. The Trimble Thunderbolt, which was a commercial unit. RS-232 again. It had a 10 meg output, GPS antenna in. Something about this was it needed, it wasn't just a 12-volt operation, it needed a negative rail as well. And I had two of these, but I brought one back from the States with me. And I put it into a box with a controller. Now, M1 DST did a Arduino Plus controller for this, which also has the bonus of you can make your own personal NTP server. So you can have all your radios and WSJT, etc., locked to one clock without having to go out on the internet with its variable delays, etc. This is my box. You can see the GPS unit on the left. This one does have switches. You can see the Arduino Plus on the back, which is very near the Ethernet connector, which is where the NTP server appears. Right, enough of history. What's available nowadays? Oh, one thing I should point out: I'm not covering the GPS units that has been discussed in NTMS for quite some time now, and measurements on it. The commercial ones that have been appearing recently in there, because that will wind up the Brits in 3 weeks. So let's see what you can actually construct today. V2ZAZ about a year ago, maybe two, updated his GPS locked his GPSDO, uses a Neo M7 GPS, uses an STM32 controller. It's called a black pill because that's the color of the PCB. There's also a blue pill that has less facilities. It's got a 16-bit DAC on the board. It can accommodate a variety of 10-bit oscillator. He publishes the settings for quite a few of them. And the good thing is the PC Gerbers are available. So you can get them made by JLC et al. In China quite cheaply. Here's the new block diagram of what he's got. 1 PPS out, 3 10 megs out. And if you look at that comparing to his PIC, he's basically using the same sort of method, but he just updated what the controller is. The there were a few issues with his software when it first came out, because there was a group of us over here trying to build it, and we had troubles where it kept saying that the GPS wasn't valid. That was because the Neos coming out of China were designed to look at the Beidou satellites, and that produced a GNRMC sentence, whereas ZAZ was looking for a GPRMC sentence. But we got that sorted out after a few late nights debugging it. So here's mine. You can see this is when I built it originally with an MV89 in. Since then, the 89 has gone on to a different project, and I've got MV89A in there from Morion. And you can see the display. It tells you time, tells you about the alarms, and you'll see that it can measure the offset and display it. What's that? That's 9.9 millihertz offset, I think, at that time. It's got 4 outputs and a GPS output, and you can actually see the raw data from the GPS as well for setting your PC clock, etc. It's actually quite good because it's got like a coarse loop, a medium loop, and a long loop. It averages over 10 samples on the short loop, and 100 for the medium loop, and 720 on the long loop. And it's, as we shall see, it is quite good. Now, a very, very recent thing, which I don't know whether it's filtered into the US or not, in radio communication September 2025, Phil Harmon, who some of you may remember was quite a lot of the backing for the TAPR SDR radios with Mercury and Annan and Mercury and the Penelope boards and the locking and all that deal, which eventually was commercialized and became the Annan series of SDRs. That also uses a Neo M7 GPS box. He uses the Pico Zero controller, and again, the PCB Gerbers are available. Here's a circuit. So there are some links at the end where you can go and look at these in more detail for the resolution we've got tonight. So it's got he's doing some neat things with the PWM to drive the oscillator. I did give him some feedback on the bomb had parts which were discontinued, because I think it's generally known around is that Phil Harmon's got motor neuro disease, and it's sort of at end of life at the moment. He's supported by pumps and machines and things, but he still manages to write articles like this for Radcom. And I think he subcontracted the PCB making and the bomb to one of his friends in China, which is why it has a lot of Chinese components on, which are quite hard to get over here. So here's mine. They did find a nice clamshell box to put it in, but unless you had some strange Chinese email account, you couldn't actually buy. So what's the answer to everything? Put it in a die-cast box. So here we are. Here's mine. I had to desolder all the connectors off the board and the GPS antenna off the board to get it in. But you can see it's got 2 10 meg outputs, a 1 PPS output. But the really neat thing, if you notice, it says SI5351 on this. That's because it's very hard to see because it's standing vertically. it has an SI5351, and you'll notice that top right corner of the box, there's a rotary encoder. This box also has a facility, as well as giving the 10 megs, you can actually set another output frequency up to, what do they do? 220 megs, I think, the SI5351s. So you can actually use this as a GPS locked signal generator as well. I wouldn't advise putting it into an antenna. 5351s are not the cleanest of things. I tried it on 2 meters, and yes, don't plug it into an antenna. The only thing that the Chinese guy who Phil got to do his design, you'll notice there's a copper heatsink. That's a linear regulator. And it takes the 12 volts out and takes it down to 5 volts. And when I first built it without that heatsink, I burnt my fingers on the chip, which was not good. But as I say, as you can see, it's quite small. Tubers are available, the code's available, and I know of at least 3 others of those that are built over here. Now, the question, how do they perform? Now, this is the bit where NTMS can probably skip, but they're in. This is for the UK audience. This, as we all know, is a nano VNA. If you look very carefully, you'll get a clue top left as to what's coming very shortly. So many will have one of those, but it can be retasked. And importantly, when you get bored of doing other things with it, you can put it back as a nano VNA to the tiny PFA, which is what NTMS have covered quite a bit before. Very commercial difference between two similar frequency sources. Some people over here try to use it to measure the difference between a 10 meg reference and a 100 meg reference, and it got very confused. And you can see there we've got, what have we got? 8 dB attenuators on both ports to keep the signal down to the level it should be. So what can we measure? ADEV, the Allen variance. Yes, I had to do some research on what the definition of ADEV was, and also finding a couple of examples of what it meant in actual jitter terms in frequency. That's right. The right-hand side of my screen is blocked by the by the video pictures. There's an example there. If you've got ADEV of 2 times 10 to the minus 10 at 1 second, it means that there's 2 millihertz of RMS movement over that period. But the good thing, of course, as you all know, is that Tiny PFA can display its data in the K5FX time-lapse software. How can I? Well, let's see if I can. Right, that's better. Now I've got rid of all the video pictures at the top right. So I did a whole load of comparisons. So I didn't have all that much time. So these are only measured over about 250 samples. So the first thing you do with your Tiny PFA is to get a source and apply equal signals to both inputs, because then you can see what the phase noise, the jitter is on the device itself, which is the bottom line that starts at 2 times 10 to the minus 12. The big blue line at the bottom, you can see it's well off the bottom. But then you can see the comparisons. The M1JZ is the top one, the purple one, which it's got peaks at about 10 seconds and then drops down again. You can see the Thunderbolt and the true position are very similar. The black and the orangey coloured ones are the Leo Bodnar and the true position, which are very close to each other. The VE2ZAZ is sloping off gradually. So in some places it's better than Bodnar, some places it's worse. It's horses for courses. It's what you want them to do. And oh yes, the reference input, I should point out, on all of these was my Alpro 101 rubidium. Oh, I've still got two of those, which is why it says rubidium #2 on it. But as you can see, it's quite good for comparisons. But seeing these comparisons made me think of, yes, but what's it sound like on the air, which is something we'll come to next. As it says here, how do they do on the air? Now, when I was last at Microwave Update in Dallas, I won the #1 door prize. The #1 door prize was a voucher to get a ZL-PLL sent to me, which I did, and I still have it. Mainly, I use it driving a diode to put markers on 47 and 76 gigs. So I thought, oh, it's small, it's compact, it'll fit on the bench. So I programmed it to generate a signal on 10368.2. I then dug out my DB6NT 10 gig transverter, which is a Mark IV. It's not the one where you can have any IA if you want. It's the one before that. And I also dug out my SDR, which was launched about a year ago. Think of it as one of the SDR radio boxes, like the RSP1 and the RSP2, but this one has got a processor in it. Think of it's like an SDR and a Raspberry Pi in one box. Because if you look at the bottom, you'll see it's got an Ethernet port. So you can remote this without a PC, and you can select the antennas, and you can use it over Wi-Fi, and it goes up to 2 gigs, I think it is. So I was using this as my measuring receiver. I did think of using the HB spectrum analyzer, but I couldn't find the GPIB lead to get the data off, or the interface to speak to GPIB. So now here's a sequence of plots, all taken from screenshots from that NRSP2. The bottom goes 14409 to 144,330. And this is just the band noise, as you can see, where the noise floor is with the ZL off. Now, as we can see here, the ZL-PLL does have some noise. Not surprising when you're at 10 gigs. And this is the it says the internal 10 megahertz crystal. It's actually one of those Chinese 10 meg references. If you remember the ones where we had to go in and short resistors out and change pots to make them actually go on 10 megs. So you can see there, it does have some sidebands, and it does have a noise peak either side. So then I put the VK6PH in as a 10 meg reference. And it didn't sound very nice at all on 10 gigs. Which got me thinking, how can we clean that up? Because I had heard that some of the wave labs are producing nasty signals as well when run from external references. So I went back and built myself a 10 megahertz 2 crystal filter. I bought 50 crystals from China, and you can use your nano VNA to actually match the series resonance frequency of them for between batches. You can actually measure them quite quickly now, because there's actually a function in the nano VNA software that allows you to come up with all the crystal parameters that you need. So I stuffed that into the German design software and came up with this very simple circuit. Yeah, so I had to use 220 puff and 47 puff, not because it needed to be that critical on value, but all the SMT kits that I had didn't have any 270 puffs. They had 220 and 390, but nothing in the 270. So I bought 50 crystals from China. Some of them didn't oscillate, so went in the bin. Some were way off frequency, but I managed to extract 10 with very similar series resonance. And because I couldn't work out why the series resonance was below 10 megs, how on earth you get them up to actually be on 10.00 megs. And discovered after quite some late nights that it's the 20 puff series capacitors which actually bring it up on frequency. Hence why the 20 puff. Different batch of crystals may need a slightly different value, but if it is slightly off frequency, it's just going to slightly drop the amplitude of the 10 meg reference. It's not going to pull the frequency. The frequency is going to stay. It's just going to be slightly less. But as most external input 10 megs cope with a wide range of levels, that's not an issue. So now you can see how it cleaned it up. So at that point, I got those little blue PCBs made and put them in all my 10 meg references. And that has helped clean up. Yes, you can still see the noise sidebands. You can still see the sidebands from the ZLPLL, but it's nowhere near as unclean. Right, and here's the links to all the what I've just been through. The M1JZ, I've uploaded the construction of that to my website as I couldn't find it online. The ZAZ Mark 1, the Mark 2. There's the M1DST, how to make the Trimble Thunderbolt monitor. And I was quite surprised, Simon Brown, G4ELI, who's behind SDR console. I saw to him 2 weeks ago, and he found 3 of the Thunderbolts in his loft, and he's now getting them going. And the first one is still working. Through position, there's a lot of exploration in the Pack Rats article there, that PDF. Oh, back. Yet another GPSDO is there. The VK6PH, all the information, although it's not quite as digestible as the RADCOM article, is on that GitHub site. The tiny PFA you all know about, and the time lab you all know about. And that's where I was going to finish, but that scared me. And also, when I was out on that 24 gig contest, there were some very, very dirty wavelag 24 gig systems out. So I thought, how susceptible is the wavelab to the 10 meg reference coming in? Because I remember way back, Steve N5AC, when he did the Apollo synthesizer boards, I remember they were very fussy about what components and whether you had low pass or not on the reference input to those. So I thought, let me see. So these were not. Here again is the ZLPLL. This is feeding my DB6NT transverter. You can tell it's my DB6NT transverter because the IF is 432 megahertz, not 144 megahertz. And this is the DB6NT with its onboard reference. And here's the DB6NT with the Leo Bodnar reference. It's the silver one that you can drive from an external 12-volt power supply. And as you can see, going between those two, there is not much difference. Then we get to the Bodnar. This is covering 1/4. This is a wider span. So it's covering 143.3 to 145.2. That's the Bodnar with no filter. So it gets wider. There's a few spurs either side of it. And now if we go put the filter in, the close-in noise, this is the 10 meg crystal filter you saw earlier. It brings it, the close-in noise goes down. Now here's the Wavelab with a 10 meg reference. This is one of those Chinese, you need to adjust the pot boards. And you can see there's some very close in-band spurious. And the spacing on those was exactly what I was suffering from on the 24 gig contest. But then you put a 10 meg crystal filter in it, and it gets rid of those in-band. Yes, you still get the phase noise either side of it, but you don't get those spikes so much either side of it. And here is the VK6PH into the Wavelab. You can see it's 144IF, which I know means it's the Wavelab. And that was wide, should we say the least. And what I was going to demonstrate, but I couldn't find the recording, is that the carrier, which sounded fine on the DB6NT, had this raspy warbling sound and did not sound nice at all. Like the early days of liner twos, in fact, somebody once said. So that's the VK6PH with no filter. And there again, put the crystal filter in, and it gets rid of the close-in side bands, and also gets the that big hump either side of the signal taken out as well. And that was the things I snuck in at the end. So if I can get back to the, there, right. Any questions, I think, is at this point?
Yeah, Dave, with the Wavelab, if you were using one of those, I'll call it $10 10 meg references, what was the filter effect again? Is it worth doing?
Oh yes.
Yeah.
I say all my well, excluding all my transverters now have a 10 meg crystal filter in them, because as you saw there, some of those I have other examples of how much it cleaned up. There was one, I forgot which one it was. I think it was the True Position GPS that when I put that into the Wavelab, produced about a 1 meg wide broadband noise at almost full carrier output. When you put an IC705 10 milliwatts into it. So yes, I've got more now, and it's what it cost me, $2 maybe for the whole thing. And then but now I can change any 10 meg reference into the Wavelab, and I know that I'm going to get not going to get those close in sidebands. So yes, it's well worth the effort. And since I've done that, I've got a 25 meg reference, GPS lock reference for locking for QO100, and I've made a 25 meg version on that, and that helps clean up the QO100 signal as well. Although that's not a Wavelab, of course.
Okay, sounds good. Thanks, Dave.
David, this is Don. May I ask a question?
Mm-hmm.
A question and a comment. First of all, thank you for a very enlightening presentation. I think you gave us all a lot of great information here to digest. I was particularly interested when you were using the repurposed nano VNA as a phase meter, with the software that was developed to do that.
Yeah.
Did you do any, and these are very, very precise measurements, as I'm sure you appreciate. Did you do any thermal environmental corrections or stability on those measurements, Dave?
No, but I did make sure that the tiny PFA had been on for 24 hours before I did any measurements to let it settle down. That was the way I could do it. I didn't do any measurements, but I'd heard on NTMS presentations, you need to let them warm up. And because on a couple
Yeah.
of occasions, I actually measured right at the start and then measured 24 hours later. The results were quite different. So at that point on, I always let it sit there powered up permanently, in effect.
Yeah, I guess, that's excellent, David. And the reason, I'm inquiring this inquiry is that, I conducted, let's say, similar experiments and determined that the slightest thermal changes in temperature of just a few tenths of a degree Fahrenheit would give you drastically different Allen deviations, or phase differences versus time. And that little NOVA, although it's a spectacular device, for these measurements, the thermal stability or the temperature changes could absolutely dominate what you're measuring. And how I did those is to send the same standard into both ports. So it was basically the same identical signals from a single source, and you could really, Matt, see what the slightest temperature change, just waving your hand, around the instrument would change the results. So it's really tricky, and I applaud you for making those measurements, because they're tough. They're tough to make.
The one good thing about having the K5FX software is you don't actually need to see the tiny PFA. And I actually did some experiments with putting it in a polystyrene sealing tile box. You know how we use the sort of lag oscillators to keep them thermal. So you could actually encase it in that and then did the measurements there. And I did them at hourly intervals for 6 hours, and I couldn't get any difference.
Yeah, exactly.
After the initial hour of warm up, it was fine. So I decided that 24 hours was probably a bit long, but it was fine.
And
I'm retired now, so I've got days to play with.
Yeah, David, you bring up exactly the point that I was sort of driving at. You really have to do what you've done there, try to isolate that from the rest of the environment. So once again, thank you.
I was going to move on to doing some phase noise measurements on them, using some software that came into my hands for my HP analyzer from just north of Dallas, but I just didn't have time, and I thought it was much better to show the on-screen, pretty displays of what the signal looked like than phase noise plots. And we all know that using the 8560,
it is possible, with some little reconfiguration of TimeLab to do a rudimentary phase noise measurement, just using the same software inside TimeLab, but it's a kludge, to say the least.
Yeah, HP did some custom software for their analyzers to do phase noise, and I've got the memory cards with that on, which you sort of press the button and away it goes and produces the plot. But again, to get that data off the HP analyzer, I'd have to find where my ProLogix HPIB adapter is, and somewhere in the loft somewhere.
Well, David, I've taken enough of your time.
Okay, no problem.
Ahead. Thank you.
Dave,
Any other questions for Dave?
Yeah, this is Al. Do you have any desired specifications for those crystals for this oscillator, or for this resonator?
No. As I say, I ordered 50 10 megahertz crystals, which came out to be something like 3 or 4 cents each.
Yeah,
I knew there's going to be some that failed.
Yeah, I was just looking on Amazon, and I have to find a store here in the U.S. To avoid any surprises, but they have like 10 pieces of an HC49S quartz
these
A23 for $8.
Yeah, I think I got 50 for like it's probably about $8. And I got because I managed to avoid the shipping charge from AliExpress by buying 25 megs at the same time. But as I say, with the tiny VNA, you could actually measure them and match them. So if there's a spread on, and they don't have to be, super temperature stable, because, as I said, if they drift, you just lose a bit of amplitude. You won't actually pull the frequency.
Yeah, I think that'd be worthwhile for us to try here.
Oh yes, it's definitely cleaned it up. I was on that on the 24 trophy. There was one station I could peak on just his Wavelab noise. He didn't actually need to put a carry up; he just needed to key it, and I could peak on that. And he was 56 kilometers away. But yeah, there's no high spec on them. I just bought 50 and selected 10 that matched.
All right, thank you, Dave.
Okay. Mm. 40 minutes. That'll do for this round table, where they're hoping to assemble 24 122 gig stations to make sure everybody's gears works, because they're going to have some 122 gig cumulatives next year, which should be quite entertaining.
Al, I could easily whip up some PC boards for those filters.
Yeah, well, I've got the Gerbers. If you just, in fact, there's a Rev 2 which I didn't show there, because I've got a little. I think I've shown this in the past. There's those square oscillators that came out of China that needed the pots on a board and a relay, and then there's a slide switch which selects between the crystal oscillator and the external GPS reference. And I've now done a PCB to fit on top of that piggyback, and I'm actually going to put the crystal filter in line after the switch, so both the 10 meg crystal oscillator and the 10 meg external reference will go through it. Every little helps. So both 10 meg references are now filtered, not just the external GPS. That's a small board. It's about 2 inches by 1.25 inches, maybe. But the Gerbers are available if you want the mass for it.
Any other questions for Dave Robinson?
In which case, I'll stop sharing and give it back to you. That should be stopped.
Thank you, Dave. Next up, we are going to talk about some rainscatter experiences. And this has 3 of us have some talking parts in this, I think. Al, is this the one you want me to drive?
Yes, please.
Moment. I'm going to be forced to put my glasses on here. Right, we should be seeing the first, the title slide.
Yep. So
would you go ahead, Al, and give me instructions to advance. And I think we also have a video at some point in here, or we could maybe wait to the end, that we will be showing too.
All righty. Well, good afternoon, everybody. Yeah, this is kind of a threesome event here. in terms of presentation, but I'm going to start it out by talking about some of the rain scatter operations that we had during the August weekend of the ARRL contest. And we do a lot of rain scatter down here on 10 gigahertz. A lot of it up north, up to Kansas. A couple of Kansas stations up there. WQ0P, NO0Y, or N0Y. And, a 10 gig rain scatter is relatively easy, it seems like. 24 gigahertz has been a little bit more of a challenge. Fortunately, K0SM gave us some enlightenment here, and we'll show you that in the upcoming slides. Go ahead, Jim. All right, this is a plot from rainscatter.com, and it's just a website that you open up, and if you're signed in, as you can see here, Jim is signed in out in EM03JW, I think it is, or 02, and a bunch of us are signed in here in the Dallas area. So when you click on a storm, you can certainly see, the coverage, and of course the coverage is quite good. But the real question is, will this help us at all on 24 gigahertz? The nice thing about this cluster is it's just like a spot or two out there. It's not like we're sitting in a big rainstorm. That'll never work, especially on 24 gig, for any sort of DX. Maybe backscatter on a beacon or something like that. But this storm was just in the right place at the right time. Of course, we had already worked on 10 gig. And that now, the next challenge was to work on 24. So when I aimed directly at Jim and he aimed directly at me, we didn't see anything on 24 gigahertz off the storm. Didn't see anything direct, because you can tell that the direct path is very close to the same path that you would shoot to see the storm. But no signals were visible at all on the waterfall. So K0SM's program suggested to elevate. So, and I hadn't used my elevation much on 24, and it's not really calibrated in degrees. It's calibrated in resistance, because it's just a pot up there. And I've used it in the past to work, I think, one of the Oscar satellites when they were on 24 gigahertz, but really had not used it recently. So it said aim up about 5 degrees. So I raised the elevation, and all of a sudden signals were there. And they were really good signals. I mean, 10 dB over the noise, and real easy to work. Now, this storm was at 50,000 feet. So basically, you have to aim at the top part of it. If you aim into it, the signals will most likely be absorbed so you aim at the top of the storm, and sure enough, it worked. And it suggested, I think, 5.7 degrees. You can see that over there. Under EM13QC and EM02JW, you can see the elevation of 5.7 degrees. And of course, that produced some real easy QSOs to both Paul and Jim. That's 245 kilometers. So I was pretty happy with that path on 24 gigahertz. I'll go on to the next one, Jim. Now, this is my array that I use for actually 10 and 24 and 2 and 3. And you can see the actuator. I don't know if you, Jim's going to point it out there. Yeah, the actuator out to the back. It's a very small one. I wish I could get more of those. They run off of 24 volts, and it's only like about a 12-inch throw, but it's got a potentiometer output. So I read it in ohms down in the shack, and I kind of made a plot of ohms versus elevation. But I took a close-up of this, and I determined that the elevation angle of the box with respect to the pipe was about 5 degrees. So that kind of gave me a calibration point, but it's really not very critical. Seems like it's more critical, in azimuth than in the elevation, but that's just my initial observation. Go ahead, Jim. You want to say something about this slide, Jim?
Yes, because this was us out here at It will be for something. Sorry, but Echo Mike 02JW. And the red box on the left side shows the way that the website was looking to us out in the field. And you can see it's talking about 8.2 degrees elevation in the bolded values. And on the right side, you see what Al was seeing, which was the 5.7 degrees. And these are new features that Andy added, which we've had conversations with him. He did a presentation. I've also talked to him since we had this DX contact on 24 gigahertz during the contest. And my question was, is there any place other than the top of the storm that, you know, would be right? And he said the value that's showing here, in our case, 8.2 degrees, is the max reflectivity point. And he said if you were to do the math on it, you're going to find it's at the top. So there you have it. And on the right side, you see Paul, my partner. He's got what looks like better than 5 degrees elevation. So, you know, he tilted back while I was working out, and he got a peak in elevation and just quit right there and locked down the elevation. Now, I had broken my tripod by this point in the contest, so I'm operating off the tailgate. And I had a couple of batteries propping up the front of the rover rig here. And I think Scott can challenge me on his elevation mechanism when he talks here. Fort Griffith. Okay, turn it back.
Yeah, I was just going to say, it kind of makes sense that you would be aiming higher than we would, or I would, because it's close. The storm is closer to you. So that all kind of makes sense. All right, then the last slide I was going to discuss here before turning it over to Scott was some backscatter that Scott and I had. And, you know, really, we had already worked on 24 gigahertz, but I was surprised at how good the backscatter was. And I think a lot of it is because the storm was kind of localized in one little area. There wasn't a lot of a loss getting to the storm because of no rain between here and there. So it just provided a good place to do some backscatter. And I think I aimed up about 10 degrees because it was closer to us. But I don't think this is, yeah, it's only 21 kilometers. Let's see, is that the distance to, yeah, that's the distance to the storm, I guess. It's 12 miles.
No, that's the distance
further than
to me, Al.
Okay, yeah, because that's up north of Gainesville. So that's probably a good 50 some odd. Yeah, probably a good 50 miles. What do you think, Scott?
At least. I think I don't know if I put that in my one of my slides.
Now, why don't you yeah, so let's just say it's about 50 miles or so. If you have it in your slide, why don't you go ahead and cover what you've got, since I think the next ones are yours.
Okay. All right, for that Sunday morning, started out in the contest. Pretty interesting morning, actually. I mean, had a lot of low-level Gulf moisture blowing in. It's kind of humid on this side of Metroplex. And looking at the APRS map, showed a lot of local enhancement at least 2 meters. Don't know if that actually translated up to 10 or 24, but signals were pretty good on 10 gig at Jim and Paul's first stop. So it was probably some enhancement there. They can go on to the next one. And at that same time that morning, storms were already starting to fire up out in West Texas. So at that point, I don't think we had tried any rain scatter even on 10 gigs. So it was a little bit later in the morning that happened. All right, go ahead to the next one, Jim. And by mid-morning, all the low-level Gulf moisture burned off. Blue skies, really nice, nice day. And this is a view back towards the storm in EMO3WC. And what I could see from here, and that red mark I've got there, kind of the bottom of the screen by the hay bale, is about the bearing for the storm from here. Now go into the next one. So the ring scatter signals were just tremendous on 10 gig. Man, it was a textbook example. As far as the 24 gig goes, nothing was heard from Jim or Paul or any backscatter from Al. I was moving the dish left and right in azimuth and elevation from 0 to 10, and just absolutely nothing. Go into the next one. And the path for me, direct path, put me right through the storm. I mean, it couldn't have been any better midpoint. And I think the storm for me was about 100 and it was 97 miles. Was that about 155 kilometers? But I don't know if the storm being directly in the path and having to look through it was the reason I wasn't able to find a signal, or possibly just didn't find the sweet spot that was actually doing the reflecting. Al, being a little bit further south of me, might have had a kind of a glancing blow off of him. I don't know. Still kind of puzzled as to why nothing happened there, but something to experiment with, I guess, at future sessions. And if anyone's got any ideas, I'd be willing to hear them. All right, go on to the next one. And for the rain scatter QSO with Al, this is a view of the storm looking to the northwest. Again, blue sky here and drier air. And yeah, that grid square is about 57 miles from here, Al. Next one. And let's see, the signal for me, when we started looking for it, I picked the storms that were kind of centered between the little cluster there. And actually, I don't know which one we were reflecting off of. It was kind of broad as far as the azimuth goes. But the rain scatter program was showing 9.4 degrees for me. And after playing around with it a little bit, I settled on 3.7 degrees, or shooting for about 4. But that seemed to be about the strongest signal for me. And one problem initially with Al was the Doppler shift. I first heard his signal and got the dish pointed and peaked and stuff. I jumped over the radio and tuned the dial to make it where it was a little more comfortable hearing. Then Al moved his dial to compensate for my shift, and then I think I'll move my dial again for his compensation. And I think we finally figured out that what was going on and stopped moving the dial and made the QSO. Yeah, go ahead to the next one.
We should have used RIT, both of us.
Exactly. And with the Yaesu rig, with the Clarify, I'm so bad about turning that thing on and forgetting to turn it off. I end up missing a QSO later down. Anyways, that's a picture of the elevation that I had at the time. Next slide. And here's my precision elevation control. So yeah, I could challenge Jim. But yeah, it worked out pretty good. I had to put it up on the Coke can boxes to just clear the side rail of the truck, and you got to do what you got to do. Anyways, that's all I've got as far as these slides go. Jim's got a sound clip / video of kind of the tail end of the QSO. First part of it's kind of noisy with the wind noise and whatnot, but if you want to play it now, Jim, go ahead, or if you want to go ahead and do the next couple of slides and then just play it at the end, whatever is convenient for you.
Okay, let me close this one out and then I'll pull it up. So here are some tips that Andy shared with us when he gave us the presentation. I won't go through every single one, but you know, the alignment, 2 dimensions, of course, as an L. Equidistant stations use the same elevation. Have to fish around. You know, peaking on 10 gigahertz. Now, I did do this, that once I worked out, I did not move the dish because I didn't want to change the azimuth that much. I saw that the storm was almost on the direct path. Use wide bandwidth and RIT for Doppler. There it is. And then the last slide I think we have is elevating the antennas on 24 gigahertz to help us beat the atmospheric loss. Install an actuator if you want to play this game. And so on and so forth. He was suggesting 300 kilometers should be routine. Well, the storm has to be in the right place, and the other stations have to be, you know, a net of 300 kilometers apart. So I really enjoyed this contact, as did my partner and the guys back in Dallas, Fort Worth, Al. It set a new record for he and I, what we share on 24 gigahertz. And it was less than a year, I think, that Andy was here and promoting this technique, and then it turned out to be true. So now I will cue up the video, and this should come across in the feed.
Okay. One additional thing I wanted to mention about the rainscatter QSO with Al and that cluster of storms. Pat W5LUA had set up on 10 gig in Echo Mike 21 and I think Echo Mike 22. He was about 180 degrees difference from the storms to me, and to work him, I was looking through the house and garage, and we tried initially with the direct path just to see if I could hear anything. And as I spun the dish back direct path towards him, I heard rain scatter on him. So, but the storm was, you know, 180 degrees behind me. So sitting there thinking a bit, it's like, what am I hearing? And spun the dish back around, and sure enough, there was, you know, his signal on rain scatter, and ended up working him and both grids off rain scatter. So that was a really good contact for that day. And definitely don't forget to check the storms out if you can't make it on direct path.
Hey Scott, is that working through the same backscatter storm that we did on 24?
Yes.
Okay. That's quite a little haul, isn't it?
No, it is. All right, go ahead, Jim.
Okay, let's do this again. I didn't do what I told Dave to do. Let's roll it back, play it again.
By the way, just a comment. There's about a 6 or 7 second delay in my TWT power supply coming on, so that's why these guys always have to wait for me about 6 seconds before they give up.
All right. Are there any questions?
Maybe we try it on 47 one of these days, Jim.
Definitely. I see there are some records in the record book on 47 rain scatter. I actually have worked you on 47 rain scatter, but I was in Salina, so I was not very far away.
Yeah, I remember that.
Okay, if no questions, we'll move on to the next presentation. Al, would you like to tee that up and share your screen and take us through that?
Yeah, I hope this works, with my limited bandwidth here, but I guess Jim, if it's, or anybody, if it's cutting out, we may have to go back to your handling the
Okay.
presentation.
Yeah, I have the backup copy here. I'm seeing your PowerPoint tool.
Yep. Let me get I'm trying to get it. Shoot. Okay, slideshow. All righty.
There you go.
All righty. This was a little fun event that we had out at the Microwave Update event. It was at the Casino del Sol in Tucson about the middle of October. And there was some discussion about working VUCC out there amongst a few of us. Tony, KZR, and Barry, V4MA, myself, had already been out there to Mount Lemmon before. And yeah, we managed to work a couple, well, what was it, 200 and some odd kilometers. So I was kind of anxious to try it again. So Tony was there. I know Barry was there, but didn't bring any equipment because he flew. Jim, KM5PO. And then I wrote down there's 4 Californians that came. Katie 6W, of course, she was the host of the conference, and Brian W6BY, and Paul A6PZ, and KB6BA were there. So let's see. Let's go ahead and move on here a little bit. So the goal was to generate VUCCs for several people on 24, 47, and 76. And most of the guys wanted to go to Mount Lemmon just for the thrill of it. So I decided to do a little bit of roving for the guys and give back, if you will, the guys like Tony and Jim that have helped me before. So I didn't bring anything for 10 gigahertz. It was all 24, 47, and 76 gigahertz. And the last time I was out on a roving event, other than 122 gig across Lake Lavon with Scott, was back in March 2019 when we went out to Mount Lemmon, kind of pre-microwave update and pre-COVID, if you will. So most of the stations were camped out in DM42 OK. So I decided to do a little bit of roving with my wife. So here's the map of the Phoenix Tucson area. And just to give you some idea, Tucson is down here in the lower part of the screen. And Phoenix is up here in the upper left-hand part of the screen. And when we were there in 2019, we worked from Mount Lemmon to White Tanks, which was 207 kilometers. So that's our best EX on 47 and 76 gigahertz. But what I wanted to try to do is operate from the Four Corners area, which is really DM33, 43, 32, and 42. So that's the Four Corners. So the question was, how close can we get to that? And it turns out the 5th grid that I'm going to go to is Heliograph Peak down here in the lower right-hand corner. So it gives you some idea of some of the peaks that are out there and some of the locations we're going to be trying to work. Well, if you go to K7FRY and you dial in the Four Corners in the middle of the field, so that wasn't exactly going to work. So I thought we would mainly do it in a couple of different times or a couple of different locations. Let's see, are these coming through okay? Do you see the yellow and the green here on this Four Corners area?
Yeah, looks good.
Okay. So we decided to operate in this area. I'd already scoped them out the day before with Emily, and boy, I tell you, this was right after they had a lot of rain out there. So we really had to be careful about where we set up camp. So we set up originally in DM 32, and then Emily drove the car, and I moved the tripod up about 10 feet to DM 33. And we were going to do a 42, 43 thing here, but since DM 42 is the same grid as Mount Lemmon, I figured those guys up on the mountain would work each other, and that would suffice. And this DM 43 location was just too wet. And you had to go far enough north that it was in really sloshy ground. And even though I had a 4-wheel drive vehicle, I didn't want to chance Emily screaming at me because I'm getting stuck. So we basically occupied DM 33 and 32, shown in the yellow and the green circles here. And you look. This is what we're looking at here. This is flat ground, a lot of rain. Looking towards Mount Lemmon. I don't think this is Mount Lemmon. I think it's still somewhere off in here, but this just happens to be one of the near peaks. I wish I had the peak finder software that I discovered later through Jim's help, N9JIM. But you can see how wet things are here. But I'm glad we checked out the area on October 13th. And the path to Mount Lemmon is 130 kilometers, really not that far for a line of sight type of operation. Now here's my rig set up in DM 3233 area, and I've got a my tripod is not set up very high. I keep it pretty low to the ground. But this is the 76 gigahertz rig on the bottom. You can see a kind of a close up here. And then on top of that, I have a plate, a metal plate. And that's set up to where I can mount either the 24 gigahertz system, which is the one that Scott was using in the prior presentation, or I can put 47 up here, or I can put 122 gig. But 76 gig is always the base here, and that's always the bottom rig. And this is basically how we operated in DM32 and DM33. You can see the 10-digit grid squares down here. So we had success from there on all three bands, and we were operating on 78 192. Turns out, I guess Tony was the only one I was working on 78 gigahertz. Now on DM43, Emily and I head out for this particular location here, which is not that far away. It's only a couple of kilometers, but it seemed to have a good view. If you can look towards the view over here towards Mount Lemmon, at least we didn't have to shoot through this tree here. So it's somewhere in this area. I kind of wanted to get more north, but as it turns out, this road here, which is, you see over here, is just full of water. And so I figured, well, nobody be on that road. But as it turns out, they were traveling on this road that I show with that green line. So we were real close to the traffic. And I almost thought about setting up there. And boy, thank God I didn't. Otherwise, I would have caused a log jam. So we were right between the washed out road and the road that people were actually using. And we had people go through here both directions. They had one guy go through on a bicycle, and one guy stopped in a pickup truck and asked us. He said he was just curious what we were doing, so we told him. And in fact, Emily told him. So she was a good PR person there. So this was a successful operation to Mount Lemmon, where we worked three bands. Everybody that was on three bands. Now that was the first day, October 14th, that we were out, and we decided to gotta do DM52 because I figure everybody had four grids, got to give them the fifth grid. And here you can see is the casino Del Sol down here in the south Tucson, and here's Mount Lemmon northeast. And then here's the heliograph peak out here in DM52. That's only a 56-mile path, but you got to drive 152 miles in 3 hours to get there. So we did that, and basically it's on interstate until you get to 191, and that takes you up to Swift Trail Junction, and then the fun begins on this road here. And I'll show you. Let's see, I got a close up. Yeah, right. I'll do this one first. Here's Swift Trail Junction, and here's the road going up to where we were, and you can see we have a bunch of switchbacks in here. So it took a while. It's about 20 miles or so. It took an hour to make it there, but it was still nice. Had a nice turnout. I don't think we didn't make it actually to the peak, I don't believe, but it was a good shot towards Mount Lemmon. And just in general, I had to look up the Graph Peak just to see how it got its name. Well, the Army used it back in the late 80s to send messages using flashes of reflected sunlight. So it's kind of like Morse code and kind of on-off keying, if you will, and mainly to in their attempt to kind of ward off the Apache Indians. So it was Indy back then, and it was only maybe in the early 1900s when they actually put a tower on it. But it does have a lot of history, and there are a lot of people hiking. I was really surprised. I mean, they make the trip up the vehicle, and then the trails on top of that, and we're up here at about almost 10,000 feet. So hats off to you for hiking a trail at that high an elevation. So Jim took a picture of me here when we were up at in DM52, and you can see with the arrow here over on the left picture, that's about where Mount Lemmon is. And you can see here now I've got the 76 gig rig or 78, and I got the 47 in position. Both of them have 1 foot dips, and it was getting a little cooler up there, but it wasn't too bad. Here's a close up to kind of give you some idea of what we were looking at. You can see a little bit of a peak over there, and that's Mount Lemmon, about 56 miles. And again, you know, I'm sitting here at 9,000 plus feet, and the guys on Mount Lemmon are up at 8,400 feet. So after 2 days of operation, 4 grids were activated on 24, 47, and 78. I assumed everybody on Mount Lemmon worked everybody on Mount Lemmon to get the other grid, but that was only the case on 24 and 47 gigahertz. Tony was the only station on 78 gigahertz at Mount Lemmon. And I guess in reality, I probably could have worked them down by the 4 grids, but didn't think of it. So on day 3, Tony and I headed up to Mount Lemmon to give Tony his 5th grid on 78 gigahertz. So if you look at his work to win, Tony was worked on every band, but the only guy worked on 78. And the guys who worked on 47, pretty much from every grid. Hold on a second. Pretty much from every grid include Jim KM5PO and Tony and W6BY and KB6BA, and the same thing on 24 gigahertz. So it was a very, very successful operation. 41 people worked from 5 grids in 3 days. Tony achieved his VUCC on 78 gig, and I achieved the first Central States VHF Society reverse VUCC for 78 gigahertz. And John Platt has confirmed that I was the first one there. So it was fun. I'm ready for the next rover trip. And this is the certificate that Tony received in record time. I can't believe it. It was received for, I guess, October 30th is when it was signed and printed. I can't believe the ARRL was acting that quick, but, you know, wonders never cease. So there's Tony with his VUCC. And I know that Jim and, well, let's see, I guess VUCC wise, yeah, Jim and Tony would have also received VUCC awards for 24 and 47, and you know, Jim for 24 and 47. I'm not sure about the other guys from California if they applied or not. I put everything up on LOTW, but the only people that downloaded or gave me confirmations were Jim and Tony. So yeah, a little bit about the equipment here. On 24 gigahertz, it was a homebrew transverter. It's a W2PED 1 watt amplifier, which aren't made anymore. A ZL-PLL, which isn't made anymore because Wayne is a silent key, unfortunately. An old Avantec LNA that I got surplus in a 12-inch dish. The 47 gigahertz is a DB6NT. The MKU LO 8 to 13 is a real nice LO. And I use that on 47, used a 47 gig transverter, and half a watt PA, which is also by Cooney, and a J8 CMY LNA in a 12-inch dish. By the way, I was reading some things today about this MKU 47G2. there were some EMEers on our Telegram little reflector that were talking about the image rejection could be optimized on this transverter. And it looked like there was a run of transverters where they actually had some resistors in the wrong place for it was selecting the lower image and not the upper, the 47088. So it may be worthwhile to check image rejection on this G2 transverter here. I've checked it on mine and it's good. So I think everyone from that era would be okay, but if you've bought it recently, it might be worth looking into. So just an observation, easy cure, just swapping a couple resistors around. And I think we're going to see it documented in the next Dubis here. I think the CT1DMK was doing a write-up on it. So anxious to read that in Dubis. 76 gig is also a DB6NT rig. Unfortunately, they're not making it anymore. At least not, as of a month or so ago. And of course, it can run 300 milliwatts, which is theoretically illegal for us right now because that would be more than 45 or more than 316 watts EIRP with a 12-inch dish. So I do have a setting on my transverter where I can only run 10 milliwatts output, and that's what I use to work Tony. So all the contacts are legit. And all the equipment's GPS locked, either with a Trimble or a Bodner reference. And I think I'm going to pull out the Trimble because it's not real clean, and or it does not appear to be, but you never know. It may benefit from a crystal filter like Dave was talking about. So I'm kind of excited about that because there's three of us that are sitting so close here in the Dallas-Fort Worth area, and we can work each other's spurs multiple times if we wanted to. So it'd be nice to work on that, at least on 10 gig. But the Bodner unit, it worked very well. And I run a Elecraft KX3, PX3. I don't like all the cables between them. It might be nice to have a 905, but I sure like the PX3. I love the display on it because you really have lots of degrees of freedom. You can increase the scale. You can make it several dB per division if you wanted to. And you can't do that with the 905. The waterfall is stuck at 10 dB per division. As far as cell phone, we used NTMS Slack, and maybe you saw that. In fact, you can go back and relook at it if you want. But there's a Tucson mud Slack section on the NTMS Slack page, and that's where we were doing a lot of coordination, plus also cell phone. Cell phone worked fine up on both the mountains. Let me back up on that. On heliograph, I think I think Tony called me a time or two, but cell phone service was kind of spotty up there, but I think it was okay on Lemon. This is kind of off the subject a little bit, but it occurred at MUD. Master Craftsman Mark Lewis, N0IO, brought his 122 and 134 gig rig. And he did that because they were going to try to break the record from Mount Lemmon to White Tanks, which is what we had worked in that spring of 2019. So he built this rig, he built this dish. He machined the dish and he machined the sub reflector. And he also machined this stand here. What a work of art. And I asked him what this was used for, and it's used for mounting his 10 gig liaison pointing radio with a little horn. So it's just a beautiful rig. I got a close-up on some things in the next couple of slides. Skip VUCC BGT took these pictures. And here you can see a picture of the feed horn on the left and a close-up of the sub-reflector. Mark had machined me a similar sub-reflector for my 39 gig dish, and that's what I use on 122. but just a work of art. It's about a 12-inch dish. And you saw the one feed here. Well, here's where he keeps the other feed, because all he has to do is swap out feeds for 122 and 134. And this one looks like it's maybe a lower frequency. I'm guessing, because it's a little bit bigger. It's probably the 122, but that's anyway, that's a sitting position for the feed. And as far as the equipment goes, if you've ever been to the Aravant website, that used to be Sage. It's now Aravant, has been for a number of years. But they've got some real nice microwave components that I wish we could all afford. But the, let's see, I'm trying to relate to what he's got here. The Aravant preamp up here is about a 5 dB noise figure and a waveguide switch. And on receive, you can see that the receive energy, you can follow the waveguide switch here, goes into the preamp and then goes into the mixer. And what happens underneath this fan is an MKU LO that switches frequency as a LO and also as a multiplier for the multiplier. It's not a superhet transmitter. It's only superhet on receive, meaning that it's like direct conversion going up to 122 on transmit. But there's an Aravant times 12 multiplier under this as well. So he gets about 12 milliwatts output on 122, 134 gig on transmit, and about 13 milliwatts out on receive. So when he goes to transmit, the output of the multiplier goes directly into the antenna. I didn't ask him, I guess, how he keys it. I'm not sure how he keys it on CW, to be honest with you. May have a pin diode switch somewhere. I'm not sure. Another question for him. But on transmit, it's the LO is at 10249 times 12, and you get 122988. On receive, that LO is at 9961 times 12 equals 119532 plus a 3456 IF equals 122988. And I said, why on earth did you use a 3456 IF? And his comment was, I can't use the rig for anything else anymore. So it was kind of a surplus rig to his needs. And he did notice several dB improvement in signal strength from 122 to 134, because everybody's been saying that the loss is lower on 134, just due to 122 being a multiple of 60, which is really the notch for oxygen, if you will. So their best EX so far has been 110 kilometers, and I think it's somewhere up around in the Pikes Peak area, because Mark is up there. And he also is very smart. His family is licensed, so he's got built-in radio partners there up in Colorado, which is convenient. But Mark is just quite a craftsman and quite a gentleman to boot. Anyway, real nice fellow. So I think this is the next to the last slide. While on Mount Heliograph or Heliograph Peak, Jim introduced me to this app called Peak Finder, and it's available for both Android and the iPhone. And he showed it to me, and he actually was looking off towards Mount Lemmon, and it actually put little arrows down and told you what peaks were which. So I've got it loaded on my Android right now, but I can't find any peaks around here, so we'll have to wait till we go out and find some real mountains or even hilltops, I guess. I wonder if it'll find Cedar Hill if I can get close enough to it. So we'll use it on the next expedition. So as usual, I always get fired up at these events. I think we all do. Either you come back, wanting to build something, do something, go somewhere. So I'm looking forward to a few more of these adventures here, and I think Jim has got a few in mind. And also, I wanted to thank my wife for accompanying me on the trip. I'm glad she was there. I hadn't been out roving in years, so that was nice. And about 3,000 miles later, we're home, but we took the long route through Fredericksburg and Montgomery to go see our son. But it was a great trip. I enjoyed it, and looking forward to the next one. Any questions out there?
Yeah, well, I got a couple, or at least one question, I guess.
Mhm.
When y'all were operating the guys, from the Mount Lemon to the different points, were y'all having to put any up tilt or down tilt, or were the points sufficiently far apart that you were still aiming at the horizon?
You'd have to ask Tony, because I was down on the deck at now 1,500 feet or so at the four corners. Um, Tony, are you still on frequency here?
I noticed a little bit on 78. How much is a little bit? Maybe a degree or two, but not more than that.
Okay, thanks, Tony.
Just
Anybody?
curious. This is Mark, WB8TG line. Just curious how strong the signals were on 78.
Well, once Tony and I finally hooked our GPSs back up, they were pretty good. I almost thought we weren't going to work from a heliograph peak, but no, they were they were strong. I would say they weren't that far down from 47. Tony, do you have a comment on that?
Yeah, I recollect that. Um, Oliver KP6BA ran a whopping 3 milliwatts, right, on 47.
Mm-hmm.
And I think you noted in your log, and from memory, you showed me it. He was maybe a 549 or a 539, and you gave us 579. So my recollection on 78 that was generally, I would characterize signal strength as 529, 539. There was no QSB to speak of. We did CW on 78. We did not do sideband on 78. 47 and 24, we did a mixture of both.
Yeah, and 24 gigahertz was like 5.9. It was quite a few dB more, but and 10 gig probably would have been even louder, but 24 gig was an easy liaison band, or first band up, if you will.
Very good. Well, congrats on the QSOs, guys.
Thanks, Mark.
Well, I owe it all to Al. Thank you, Al. Thank you, thank you, thank you.
You're very welcome, Tony.
Hey, before we take more questions, let me just show the video of Tony doing the CW dance here. So stop sharing now.
Okay, let's see. Stop sharing.
What? There's a recording?
Yeah. All right, get the audio feed going. Here we go.
right, a carrier again, please. Okay, that's good. I can give you a call. I'm going to turn the speaker off on the phone here, and then I'll give you a call. Here we go.
Okay, I hope you heard that. And that brings back a memory, Tony. Al?
Yeah, I guess I was going to say that's running the Trimble GPS locked LO. And I don't think it had always been like that, but when comparing it to the Bodnar, it's not quite up to snuff, but I couldn't swap it out while we were, roving. But I think that's the change I'm going to make. And it may just be aging, or the crystal filter may be the solution. Any other questions?
I just have one about the 134, 122 station you showed. You got any idea what that multiplier and mixer and goes for?
A lot.
A lot?
Yeah.
If you have to ask, you can't afford it. Okay,
Yeah.
thanks.
Yeah. No, it's thousands of dollars. It's you're buying commercial equipment.
Okay. All right, thanks.
Mm-hmm.
Always a lottery.
Yep. All right. Well, I guess that's it, Jim. Thank you.
All right, thank you, Al. Wow. Never know where your files are these days. Okay. I wanted to capture some of this because I'm not sure how many more trips I have in me. And I did some things on this trip that I may never do again. And a lot of the travels brought back memories of being 50 years younger and growing up and, exploring forever from El Paso and all points in between. So this is kind of a chronicle of my trip and some of the stuff that I experienced, along with some views from the top of Mount Lemmon and the motley crew that was assembled there. So my first leg was to just get out of town and I was destined to stop at Sunspot Solar Observatory, which I had done some homework on and had called the folks and looked at street views and, everything I could to try to determine if there was access to the desert floor beyond and what kind of rover location it could be. And I wasn't disappointed. But anyway, this first leg was 10 hours long, and I left at 3 a.m. I probably didn't go 100 miles, and I had to pull over and take a short nap. And then after that, I was good, and sun came up, and I was on my way. So here's this kind of a broad, high-level look at Sunspot Solar Observatory. And it's parked up on the top of Sacramento Ridge or Range, and the Sacramento, very near the Sacramento Peak. And the observation areas are right near the cliff where, the west side of the mountain falls away. The visitor center is over here to the upper right, and I went in and met the volunteers and the people that work there, and I got to talking about ham radio, and I asked them about operating from the scenic overlook, and they said, oh yeah, we have guys come up here all the time. And in fact, says last week they had a big assembly out in on the concrete pads in front of the door, which is what's showing in the upper right picture. And she said it was a coronal mass ejection, and they were, up there bouncing signals off the ionosphere. One of the ladies actually married to Kilo Mike 5 Mike Bravo, which was amazing because that's so close to my own call sign. So anyway, one of these telescopes, I guess they are, it's not really in use anymore, but I've shown the below ground kind of extension where the mirror, objective mirror at the bottom is focused, no doubt, up here on the observing room floor. And that's this white structure you see over in the left picture. And you can walk right up to that. And then you see this sign lower right that says scenic view. Well, that's where we're going. So down at the bottom of this picture is the visitor center that we were just showing. And you're going to have to walk about 300 yards up to this scenic overlook to operate microwave. And it doesn't look like it, but it is hardtop. And people were carrying kids in buggies, and I saw a motorized wheelchair all the way up here at the scenic overlook. And it kind of makes a loop if you wanted to do the loop thing and come back this way. But I just was headed straight up there to the observation deck. So this is kind of a mosaic of several pictures that kind of show the view on the left side of this abandoned building that you see to the far right. That's White Sands Missile Range, Wismar, where my dad drove to and from when we lived in El Paso, and he was an engineer with Raytheon working on the Hawk missile. They would fire the missile there. And that's also known as the Tularosa base, and a little further over to the right. That's where we're going to find 4 grid squares that come together. El Paso's back to the left, kind of might be at the edge of this pine tree. This is looking back from where you can see this ramp coming up, and this is a step up to an observation deck that has a telescope where you drop the quarters in. And then, there is a fence in this picture that's over here to the left side, but that was no longer there when I visited. And you can actually walk right out to this concrete pillar with this tower on it. This looks like the same tower I have that's on my trailer, so it's portable. And I wanted to mention that in 1964, 5, 6, 7, when I was discovering 2 meters, I could hear a beacon on 2 meters from Sunspot. So I postulate that might have been coming from a beacon mounted on this tower. This tower's got a winch at the bottom. The cables are all corroded and rotted. But I just wonder if that's where it was. And maybe on subsequent trips, I'll get to clarify that. Anyway, here are the three locations that I went to and checked out pretty careful. The one on the far left is the one that we just got through showing, where it has the step-up observation deck with the telescope. The empty building is kind of hard to see because the rooftop is black in this picture, but it's just right here. I looked in the windows, which you can see on the other side, the north side, and there's just some shelves that are kind of falling apart and no equipment of any kind in there at this time. There's a dome right here that looks like it might have a telescope in it, in this middle section, and you can come right up to the edge of this cliff. There is no fence here, so it would be a dangerous thing. But the guy on the motorized wheelchair he had actually gone up this path and was right in between this building and this dome. So, he wasn't too scared of it. And then on the far right, you can come up here and you, again, get right up here at the very edge. So there's several access spots. Here's the four corners. That is a very easy line of sight shot from the observation point. Down here, just north of Alamogordo, south of Tucumcari, or I don't remember. But anyway, this is the four corners that you would have a rover rotate through and give you back, four grids. Now, one of these is in the same grid as sunspots, so that contact can be had in a couple of different ways. But you'll see when I show you the detail, these locations are pretty easy to access. And then going back to DM61 to give you the fifth grid, there is a very good spot right at the Texas line, which is what this boundary between DM72 and 71, 62, 61 happens to be. That is the New Mexico-Texas line, north-south. Now, the Rio Grande would etch another chunk out here. But anyway, Newman, Texas, and that gives you the five grids. I did put the link here to this tool, which is kind of nice. You can zoom in, you can zoom out. Here's the detail of the four corners, and the blue lines, aqua lines, these are the delineations for the four corners. There's a curve up here a guy could set up in. And then there's two locations on the side of the road down here in the lower left. And then there's one over here that's at a public entrance, or it's a dirt road that goes up into this little community of this little settlement. For Al's sake here, this is theodolite, but I have the Peak Finder overlay, so it just automatically kicks in. And these are Peak Finder mountain notations here, which don't really help me here, but it comes on, it just comes on. So the Tularosa Basin is over here to the right. It's really closer to the edge of this 2.9 negative elevation readout here. And you can see from the profile that it's a dead line of sight, and it's not very far. It's 17 miles. Here is kind of a tilted Google Earth Pro vision of it. And so you see the red line heading out here to the location of the four corners. This other ray going down here is to Newman, Texas. North Franklin Mountain is a few miles north where I used to live in El Paso. So, and you'll see this arrow that Al called it is coming down into this haze. Well, we had low level. This rainstorm is about to get to us. And so this was kind of a leading edge of low level clouds, or else you'd see the mountain there. So it's going to put Newman right at the edge of this tree. And I'm standing in the upper deck when I took this picture. You could also get away from this tree if you worked on the other side of the building. Here's the path profile. Again, it's pretty much a line of sight shot. Shouldn't be a problem. There's another ray shot to show the path to Newman, and the setup is done at the corner of a road called the Edge of Texas. 99.6 clicks. Okay, so then to continue on, I had come up through Cloudcroft and down this road to the Sunspot Observatory, so I had to retrace part of that and then come down the mountain into Alamogordo, where I would stay overnight. This is a travel down memory lane because I ran a motorcycle off the road somewhere along this blue path, probably where that zigzag is, but. Yeah, I was up there. We'd go up on the weekend with our sleeping bag rolled up behind us, and a few of us guys on our motorcycles, and a bottle of whiskey, and just do stupid stuff to kill time. And one of those times, the road was damp in the early morning, and I slid that Honda 305 off the road. And we spent the whole weekend getting that motorcycle out of the field where it had finally come to rest, and I left the bike and it hit a tree with my helmeted head. But anyway, going down this road, all those sights as you get closer and closer to the desert floor brought back so many memories. Now, this was leg number 2. I was about to hit some rain here. I was going to drive here from the hotel in Alamogordo up through Las Cruces, through the Oregon Mountains, and then up north of Deming to Silver City, and finally to Glenwood, where I had a cabin rented, and that was going to take 4 hours. The hotel room made me feel at home because it had a painting of the Oregon Needle. Here I am driving up the road, and you can see the Oregon Needle. It's this gap right here. And it just reminded me so much of a lot of things. I had an obligatory stop for the Border Patrol, which runs those east-west roads, and they really have a lot of stops if you look it up. And I ran into no cell service. And so there's a story here because I left Silver City and didn't pay attention to my phone, really. I just wasn't paying attention. And I got all the way up here to my cabin, and I realized that I didn't have a signal. And I realized that the lady had fixed my reservations, had sent me the door code in my email. So I had no way to know what the door code was. So I end up going back to this spot. It says Buckhorn. You see there's a little blue dot right there. I drove all the way from Glenwood, watching my phone, watching it until I saw one bar come up, and it was here at Buckhorn. And there I was able to retrieve my email, get the door code, and go on. Now, what am I going to do, with the XYL? Well, this is, I don't know if you've run into this, but I have AT&T, and I went over to text her, and this thing on the left side pops up, and it says, point to the satellite. And so I did what it said, right? And so it started, you see this green haze like a signal, that started going bi-directional, and it locked. And it said, keep pointing at the satellite. And then there were these bursts of green energy would go up, and a burst of green energy would come down. Obviously, to let you know that, you're pointing right. And if you would move your phone, your green energy would move with it. So it wasn't too hard to do this. It shouldn't be any step for a stepper, right? And we've been doing Leos for a long time. So anyway, I was able to talk to my wife and be in touch with her until I got back into the room and got on Wi-Fi. And here was my cabin. This is the whitewater canyon up in here that I wanted to visit. And but man, it rained and it rained and it rained. And there's my dish all covered up. I had furniture covers and had the gear well secured. However, I was going to find out later that my toolbox was not covered, and it took on water. This is known as the catwalk, and it's I recommend it. It is handicapped accessible as well. you won't be able to go everywhere near the end of it because there's stairs. But Whitewater Creek comes off of Whitewater Baldy, 12 miles away, and beautiful cold water, white water. It's got rapids and waterfalls. And this was my stomping ground as a young man fly fishing up in here. And here's where the catwalk on the right side, the catwalk ends right here with this stairway and then turns into a concreted path. And then over here to the left, the path continues over these rocks where some of the creek is running across these rocks. And then this pathway disappears up in here. And I was here 51 years ago, but I was coming down out of the valley, and this hard surface was not here. And we waded the creek multiple times that day, me and my brother-in-law. The rain had started, but it was not like we were going to get, and it washed out several places in the road. And this is a typical 5 or 6 inch deep wash out of the road. So the third leg was, again, just leave at 3 a.m. and try to make Mount Lemmon by 9:30. And here is where we caught more rain. And this drive across the Arizona-New Mexico line was something else with terms of 20-mile-an-hour curves and slow going. Here is day one. Here are the participants attempting to work and successfully working. Al and his magic location, as they called it, Maricopa, Arizona, right to left. That's Brian, Whiskey 6 Bravo Yankee. And then this is actually Joel. I have him named later, but this is our chairman for the conference. This is Oliver's rig, so he's probably not far away. And here's Tony's rigs, and I think that's Tony back behind there. My stuff is kind of covered up. Here's a view from higher up on the hill, and that's Tony clearly there. And then Al is over here in this direction. And here's another shot of Tony working Al on 10, 24, 47, and 78. He's got 2 of his rigs on the tripods, and then he's got 1 on the ground. And he was, back and forth switching these often. That's Oliver, KB6BA, behind this big monster dish. Here's my stuff. I had to take everything out of my toolbox as it all got pretty drenched. I had some of the fragile stuff in other packages and boxes, so I didn't take really any damage. And then this is my 10, 24, and the 47. This is day 2. The weather really turned out nice. We had light jacket for most of the day, but we're set up in a different location here. You can see some of these dishes, like this one here is Oliver's. He's pointing over here to the left. This is me and Tony here, and it looks like we're pointed back here to the right, which is where Al was at. We had a lot of visitors drive by. Those of you that were there, I guess it was Tony, and one passerby stopped and turned out to be a lady that was licensed as a ham operator and got her license specifically because it was the only way to communicate with her father, who did not have a telephone. I don't think he was off the grid, but he didn't have a phone where he lived. And so they just would communicate with Morse code, she said. And so she was, familiar with some of what we were doing there. Here's another hand shot, sort of. Joel's out here on the far left. I think he's pointed back to Maricopa or other points that way. And then you can see us sprawled out here along the road. Here is the overlay of Peak Finder on top of theodolite. And Al is at this red dot, which is a location feature that you place on the map ahead of time. So you zoom in like you're using K7FRY, You set a dot where the exact place that he's going to be. And then when you exit the map, it shows up as a red dot like this. So it's not really that important to know bearing, provided you have the technology and it's working. Because if it's, if you don't have cell signal, then you know what? And there's 10 degrees of declination in Tucson. So, I have this reading out to me in magnetic at 66 degrees. And, there's heliograph and his grid, DM52 Bravo Papa 65 Mike Sierra. Here's the drive. I wanted to throw a few pictures in here to remind me of this drive. Thimble Peak is this little tiny, in this picture, a little tiny bump over here, but this is up at higher elevation. And as you come down, you see these rock formations with erosion that are pretty amazing. I thought this was neat because these little rocks up here look like they're about to fall any second. Here's the lower elevation. You start seeing this cactus. And then we come to the update itself, microwave conference itself. And this is Tom Williams explaining how to select a frequency on the RF0. He had some amazing developments there that we'll cover in another presentation at some other time. This is Mr. Ben Lowe over here on the left side, and he's got what he calls the quick fix Trojan antenna, the quick fix Trojan antenna. And I just had to put this picture in here. I'm going to build one of these. This is built around an 8.5-inch diameter clamp lamp from Home Depot. And he had these papers to hand out that have templates on them. And so all you got to do is follow the instructions, and you too can have one of these Trojan antennas. And he was able to pack this, I think, in a backpack to fly out to Tucson. Pausing for Ben to come off mute. Okay, we'll move on. Then the end of the story is the return home, which I did in a single pass of 15 hours of driving. I think I stopped once when I thought I was getting sleepy, but I don't remember staying off the highway very much. Got to get gas a couple times, but yeah, it's a long ways. And of course, you have the obligatory Border Patrol stop outside of El Paso. Oh, it's closer to it's closer to Midland than El Paso.
KM5PO, K4QF.
Go, Ben.
Yes, I finally got my phone unmuted, but did you have a question or something?
You were able to get that in a backpack, right? And did you bring it on the plane, or was it checked?
I brought it in I have a carry-on bag that fits the size for carry-on luggage. It will go in my backpack easily, but I have a carry-on bag, and I put the antenna, a camera, tripod, a battery, everything I needed to operate in the carry-on bag. And I was surprised that, of course, TSA ran it through the x-ray, but on the way out to Tucson and on the way back, they never opened the bag. So it went right through the security check without any hesitation.
What do you reckon the gain on that horn is?
Well, I've got two measurements that I did not do. I got someone else to do. I got one measurement was 20 dB. Now this is at 10 gigahertz, and the other measurement was 22 dB. A little bit more than a standard gain antenna, but then it's got a little bit more aperture area than a standard gain horn too. And of course, it's very, very lightweight and very cheap. I think that reflector was about $14 or $15 at Home Depot. And then I made a VE4MA or W1GHZ. I forget who did that particular coax to waveguide transition, and I just put it in the back side of the reflector, and fit right in there. I did have to take a piece of a thin wall PVC pipe and make a little shim, but it went right into the back of the reflector. Of course, normally that reflector is used with a light, a lamp, and I took the lamp out and discarded that, and then made a little interface plate. And the whole thing probably from start to finish you could build in 2 or 3 hours.
Yep, I'll report back because I'm going to make one. I think on some of these adventures, I would like to have 10 gigahertz for liaison, and this would kind of fit the bill.
Well, they have 2 other size reflectors. This was I think this was an 8-inch reflector. They also have a 5-inch reflector, and they also have a 10-inch reflector. But of course, I wanted something that would fit in my carry-on luggage.
All right, thanks for that, Ben.
You're welcome.
Okay, so I'll resume here with poking around, just looking for DX distances. I started seeing some north of Phoenix. And so I started chatting with Joel, KD6W, really knowledgeable fellow there, along with Jim in 9JIM, whether or not they had considered Crown King, and that's the name of a little settlement, got its name from a gold mine that was named Crowned King, that they pulled about $2 million worth of gold out of 1920-ish. And anyway, a little settlement, is still there now. It's got some very nice homes and one-room schoolhouse, and it's small. But anyway, there's not only Crown King, but there's other locations that are even farther to the north. And so I just started chatting with Joel. First, I'll show you this path profile on curved earth, true line of sight. You can see that it's dead LOS as long as both sides don't have trees and they're just looking out over the cliff. Looks good. And I did the link budget, and I need to vet this with second set of eyes. But on the left, I picked a warm day at 50% humidity, typed in 250 clicks, conservative on these values here of 24 dBm for transmit power. I think that's about what mine is, about 300 milliwatts. 40 dBi antenna on the transmit side, 6 dB noise figure, 2400 hertz, sideband bandwidth, receive antenna gain 40 dBi, and I come out with 23 dB signal to noise down here, which would be plenty strong enough. And then on the right, the only thing I changed was the temperature, took it down to what Barry hopes to get to, 7 degrees centigrade. That's 40, something low 40 degrees Fahrenheit, and took the humidity down to 30% and got a 20 dB improvement down here at the bottom. So unless I've done something really wrong here, this would tend to give us a hint that, 250 kilometer line of sight might work. Joel gave me a reply, and here's what he ended up telling me. I'll have to narrate what he told me, but basically this looks a lot like what Al had earlier, where Mount Lemon's down here in the lower right. The magic spot over here is where Al worked from, DM 33 and 34. This is going to be Phoenix. So this is probably White Tank right up here. And then right here is Crown King. And then he's got question marks up here and more distance up here.
Yeah, Jim, it's Barry. We were looking at Mount Union back in 2019, and the problem with Mount Union was it's not a well-traveled road, and if you were trying to do it with low dew points, you might have problems with snow.
Yep.
But that was also a line of sight shot, but kind of on the edge.
Yeah. Well, I think the first one is interesting to me because they've got cabins for rent up there in Crown King, and a guy could plan to stay up there a couple of weeks and four-wheel it around some of these roads to find the good shots, and start there and just kind of understand what you're up against. But we'd love to have these problems in DFW.
A question for the group. Are there any hotels or lodges to stay at in Mount Lemmon where we don't have to go down the hill back to Tucson? I can't remember seeing anything up there.
I guess there's probably bed and breakfast, or what do they call them now, in Summer Haven, the B&B.
I'm not sure there's a bed and breakfast in Summer Haven unless it's come in pretty recently. Pretty much, if you're not working with the astronomers, they have a sleeping area up there, but otherwise you have to come back to the bottom of Plymouth.
Is that Jeff?
Yes, that was me, Al.
Yeah, thank you, Jeff.
So that's kind of my report, and I think that we'll probably be soliciting for folks that might be interested in going back at least to the El Paso area and earn VUCC or get an endorsement for 5 more grids. Any other comments or questions?
Well, I guess it would not be an endorsement in El Paso, right? Unless you initially get your 5.
Right. No, like it would be for you to get a second 47, so an endorsement for 47.
It looks like some of those peaks are soda summits as well. If you got 4 contacts, you could get the soda activation as well.
Do you see what I mean, Al?
Well, yeah, but endorsements are usually for after you get an initial application. You can get multiple VUCCs. I got one for Mena, Arkansas, in 3,400. So I think, is that what you're referring to? Just multiple VUCCs?
Yeah, I guess I should call it that rather than an endorsement, because the only way to get it, the real endorsement, is to work 5 more from the same location where you got your original VUCC.
Correct.
Yeah. Okay.
Hello, Jim.
Yes.
Yeah. One other thing about the rig to carry on the airplane, which went in the overhead rack. I got a 6 amp hour 12 volt lithium iron phosphate battery, and the airline rules say that if you bring that type of battery on the plane, you need to keep it in your carry-on luggage, because if you do by chance have fire or something with it, they have the equipment in the cabin to handle that. They do not have a way to handle that if it's in checked baggage. And so I also had the battery in my carry-on luggage, but 6 amp hours, I figured my demi transverter would take a little less than 3 amps key down. My ICOM 705 took less than 3 amps keyed in. So this battery should run the entire rig for an hour keyed in. So I figured intermittent service, I could get 4 or 5 hours out of it.
Ben, I have some bags which are certified for lithium batteries, designed for shipping them, and they're incredibly fireproof. They kind of look like a bank deposit bag.
Okay. Well, can you check those? Can you check those bags?
They look like a bank deposit bag, but it would make your lithium battery far safer.
Well, it would, but I mean, I just put it in my carry-on baggage and put it in a Ziploc bag, so there wouldn't be any danger of shorting the terminals. The terminals are not visible. They have an Anderson power pole plug on them, but you got to get inside that plug.
Well, with lithium batteries, it's the internal failures that are most spectacular.
Oh, I can imagine. But anyway, it is legit to carry them on the plane as baggage.
Right. Any other comments before we run through the last of the slides and wrap it up here? Okay, so I'm going to roll through this. We've been through the technical meeting. Remaining here in November, I guess it's this weekend that there is the ARRL EME contest, 50 through 1296. And then for you ping jockeys, the 17th and the 18th is the Leonids. December, we will have our activity day on the 6th. And on the 13th, we will have another meeting. This is the meeting that we have the elections. And I'm going to ask for a volunteer or anyone to raise their hand by contacting me directly or Al if you're interested in holding the vice president role. Matt Kuby has told me he wants to pause because of his kind of his work-induced move that he had to do. And the 13th and 14th, we have the Geminids. January, the 3rd, those that are around, we will have an activity day. And then on the 10th, we have our next meeting. And then the 17th to the 19th is the January VHS contest. Here's our perpetual stuff. I read this every time, but I'm not going to this time. That's all of our activities that occur weekly. I should call out the Hoot Owl Net and the NTMS lunch, which has a number of people that attend over here at Texas Smokehouse Barbecue. I'm going to call for if there's any old business to discuss.
Oh, Jim, I got a comment on January. Is Cowtown still going to take place?
Yeah, I don't have the dates and I didn't put them on here, but I'm part of that club and we're meeting Monday to discuss the initial, who's going to do what.
Most likely it's the same weekend as the VHF contest.
Yeah, it could be.
It still works out.
Yep. Okay, any old business? I do have some new business to go over, but does anyone have any in the audience?
Maybe old business related to the beacons. We need to schedule a trip over to the dorm eventually.
Yep.
We got some rigs to be brought down and probably can't fix anything on the spot, but probably we can get up there and measure some things and make sure that something is kaput if it is. If not, we'll leave it there. But we got to kind of plan something here. Because we do have a 3400 beacon that could go up there and do things like checking out the power of the 432 and the other beacons that are there, and pull the 304 because it really did go kaput several months ago, and bring that one back and work on it.
I made a note. We'll have to pull together a posse, and as you've listed them here, go with a plan.
I'll contact Gerald and see where things stand. Maybe we can do it in between holidays where their parking will be easier.
So you're going to contact Gerald?
Yeah, he's the guy we go through from the Denton Club.
Yeah, I think over the Christmas holiday would probably work for me, I think.
Yeah, we just got to see we're at the mercy of a IT employee. It has to be during the week, and we're at the mercy of them now.
Understood.
Okay. Was that all?
Yes.
Okay. We show this slide every time too. And the bottom line is we need your $20 annual dues. And donations are welcome. Now, on the subject of staying flush, which is, I guess, one of the things we can call it, is that it takes 45 supporting club members to equal our operating expense. And our account is averaging a drop of $500 every year for the past 5 years. So I can do the math without asking Wes what's in the checking account, and I can see that we really have about 20 people supporting. So I'm asking you again, please go on the website, renew your membership. There is a button to push where you can PayPal your $20 or 21 if it's a family. And I've covered this before, but there's definitely a finite amount of time we can stand the current drift down. I'll mention this again, that we have a lot of visitors to the website, and it really represents one of the big resources that we push and pay for and see enjoyed by many every single month. Total number of hits can reach over 20,000. We have presentations and materials, artifacts downloaded every single day. I did this back in July, but it was the number of visits and how it perpetuates through the year. You can ask these are instructions really for me if I was going to do this in real time and show you, but you can follow these menu options to find what people are downloading, where they're coming from, what countries they're in. And here's another plea for membership dues. Down here, there's a select box where you can pick $20 or $21 and click the button. And then this is one way to donate. I appeal to you that no information is truly free, even though we have a society believing that it's as easy as opening YouTube to get whatever information you need. And while that may be true, somebody had to pay for it. And we're very close here as a community, and we can just take this responsibility that if we don't do something about it, that finite point will come and there will be trouble, and it'll probably be handed down to many of the younger members of our club today. So here were some of the next steps here, and I'll cover this. Place a donate button on the homepage with the phrase, if you like what we're doing, please donate. I put this on today, so it is out there, and I tested it, and it worked. It took my money through PayPal, and it sent it to Wes. So that's done. Irving Club provides what they call micro grants. I've learned since I wrote this Word old program that this is still an active process. And David is here, I think, in our audience, and I've asked him to help us work with Irving to show them what we could use money to fund and see about signing up.
Already reached out to him.
Thank you.
Yep.
A couple of years ago, Al told me I should be looking at these grants from the ARRL, and I took a look at the paperwork, and I was just real busy at the time. I would still like to seek a volunteer from someone that could help me with the whole thing. I mean, there's several forms to be filled out. There's just a concept has to be expressed, and I want to do the right thing here. We've got a couple $1,000s invested in this multi-band beacon at this point. We could repair, modernize a number of our other beacons. Imagine adding WSJT to several of those beacons that we currently have. And that could be set up over a period of years to do that modernization. We could also add the remote control features. We're learning more about how to do that more economical. So there's that. Now, before I do this, I want to show you the new website donate button. And I probably have to do something smarter than what I just tried. No. See if that'll work. Just about get good at this by the end of a meeting. Okay, here's our please donate to NTMS right up here. It's the same place it used to be, but I've replaced the link to the donate page with this script that you basically get from PayPal. And I want to, this now shows up everywhere that you navigate to on the website, but I want to add additional instances of this in certain areas where we have rich, I say more rich current content. So it's just to be a reminder that we'd appreciate your donation.
Hey, Jim.
Yes, sir.
Is this in addition to the dues? I assume it is, right?
Yes.
So where would the dues be? Is that over on the left somewhere?
Yeah, it's right here under membership.
Okay, I see it.
Yeah. And
Jim,
then
would it be possible to merge the dues membership stuff with the donate, so while somebody's got their wallet open, they see the donate there and
yeah,
for membership?
That's a good idea.
Hey, hey, Jim.
Yes, sir.
I think there is also a provision with Amazon that you can have a percentage of your Amazon purchases go to your charity of your choice. That might be another source of funding.
You do the same thing with grocery stores too, like Kroger has a program.
Okay, well, those are some ideas we can see if we can percolate, but we can certainly follow Scott's suggestion here.
Jim, did you say you're active in the Kilocycle Club?
Helicycle?
Fort Worth.
Yeah.
Who do I need to talk to about getting my tables back again this year?
I can definitely bring that up in the meeting Monday. Do you mean you just want the same location, or do they have your physical tables?
The same 3 tables that I've had for several years.
Okay. I think they would be shocked if you didn't show up.
Thank you. I think.
No, I think you're kind of the fixture, one of the fixtures down there.
Do we want to try doing a NTMS presentation?
Oh, yeah.
Okay.
I mean, I haven't talked to you about it. I figured we'd just do the same. How to get started in microwave. You know, you've got your way of communicating that appeals and people love it. And then I've got mine.
Okay.
I want to bring your attention to one other thing, and that is, well, first, before I forget it, I had to delete or empty my cache, my files. And that's all I did in order to see the donate button and the new link over here that says special projects. So on my browser, that is like, what is it? History? No, it's not history. Delete browsing data. And then all I deleted was this. Cached images and files. Otherwise, I couldn't refresh my browser to see the changes I made to the website. So you might have to do something similar. It used to be I could press Control 5 and it would fetch the pages again, but that didn't work for me. So special projects, if you click that link, there are 2 further links. One is Scott's files that he has curated from his collection and has sent actually to the group in an email. And then this one is the data area microwave history. And so this is a conversation that started with Ben and has been back and forth with Kent and a couple of other folks here. And all I've done is just put everything up here that was passed back and forth in email. So I'm hoping that these, conversations will continue and that we can add to it in time. But I wanted to capture this at least right away. And I just got the biggest kick out of Ben's story about Leroy having the shared tube on the week that they flew the balloon over Dallas-Fort Worth. To share a tube, right, Ben?
A blimp.
A blimp.
Yeah, to test air-to-ground communications, and that was Dr. Dr. Ahoyt Taylor out of the Naval Research Lab, and this is 60 or 70 years ago.
Yeah. More than that.
Well, I can almost believe that pretty soon somebody will be sharing an ICOM 705 among 2 people or 3 people. But I can't imagine being at a place where you have a single tube that you have to share with your friends at school. And then he got lucky enough to have it the week that the blimp flew over.
Ben, are you sure Leroy got a WAS on 5 meters? Because it was my understanding he was close.
I'm not sure. I'm not positive about 5 meters. I know he had one on 6 meters when it was 48 states. I think he had one on 5 meters, but I'm not positive about that.
Okay. I've never seen a listing showing a WAS on 5 meters by anyone.
Well, it's a little sorry, but it's a little bit too late to ask him.
I understand. I'm not sure we should have it in history, but okay. Yeah, Leroy got his 6-meter WAS 2 months before I was born.
Well, I'll just say there's a lot of history with the W5HN. Well, that was W5HAG, but there's a lot of history in Leroy's ham operation.
Exactly. You could look at almost any issue of QST, and at the states worked, and he was usually the leader of the 5th Call District. And he had a lot of stories about, oh gosh, I'm embarrassed. The editor of 73 magazine for so long, Daryl Wayne, who Leroy was a teetotaler, and Wayne would come over to his house with a 6-pack of beer and sit on his back porch drinking. Yeah, that was, there was one issue of 73 magazine where Leroy had 5 articles, technical articles in it.
Oh, and one other thing I did not write about, but I'll just mention it. There was a guy there in school at SMU. I think Leroy said he was studying physics, named Jimmy Trexler, and he came over to Leroy's house, and he visited with Leroy quite often. But after he got through school, he went up to Dallas and went to work for Naval Research Lab, and he built a 200-foot diameter dish with a line feed like they had at Arecibo, and Arecibo was patterned after his 200-foot dish. Of course, Arecibo was a 1,000-foot dish. I'm not sure if Jimmy Trexler was a ham, but he was a friend of Leroy's.
I remember chatting at length with Leroy about getting what they called a reflex radio working. A little touchy when you use the same tube for 2 different purposes.
Yeah, well, like I said, the good old days are now.
I remember when we had to use those things called gas fits. That was before they came up with the molecular valves.
I don't remember that. I must not be that old.
All right, guys, I think we've come to the end.
Okay, 73 all.
Make a
Thanks
motion
for all
that we
the
adjourn.
presentations, guys.
Motion that we adjourn. Anybody disagree?
Second.
Second.
Got it. Thanks, guys. Stay out of trouble.
Have a good weekend.
Thank you.